Hello friends, welcome to SahuStudies. In this video, we are going to discuss how ReduceByKey function works in Scala. So what is ReduceByKey function? ReduceByKey function is a transformation function. It is a wider transformation function. So whenever you are going to do any kind of a transformation, generally we use any transformation function and ReduceByKey is one of them. And it is a wider transformation. So if the transformation is wider, that means the shuffle operation will going to be happen. But the good part is that ReduceByKey do the shuffle operation at the last stage of the transformation. ReduceByKey is merge the value for each key. Suppose we are going to do any kind of aggregation. So suppose here the aggregation we are going to do with the sum. So how the ReduceByKey function will works? It will see the key and it will going to merge the value of the same key. So suppose there is, suppose in the RDD there are 100 keys are there, and out of 100 there are 10 unique key. So for each key it will going to merge. It uses associative reduce function on PySpark RDD to merge the value for each key. So whenever we are doing any kind of aggregation, so suppose we are doing the sum aggregation, so it uses the associative reduce function to do any kind of a merger on the value of the each key. Here, if you are not able to understand what I'm just if I'm talking about, it is used to merge the value of each key. If you are not able to understand at this point of a time, it's okay. Let me do the exercise. When I will show you the output, then we can get to know that how ReduceByKey merge the value of each key. As I mentioned that it is a wider transformation and hence it shuffles the data across different partitions. It operates on the pair RDD, the key and the value pair. So one of the key feature of reduce is that although it is doing the shuffling, but the shuffle operation happen at the last step of the transformation, and ReduceByKey operates on pair RDD, which has a key and value. So suppose we have this data and this is the key and this is the value. So what ReduceByKey will do, it will going to take all the value from here for this key, all the value from this key, and all the value from this key, all value from this key. So it will going to reduce, or it will going to do aggregation based on the key, and it will merge the value of the same key. So we can see here this ID. If you see the sum, it is the 5 because this value is 5 times. 5 times is there and the value is 5. Same is for operation. Operation value is 8. You can see this is operation, this is operation, this is this one, and this one. So there are 8. If you just calculate the value, so this if you add it, so 8 value you would get. That's why here it is the value it is showing 8. Now for the management it is 4, marketing 4. Management, how many times it is coming? It is coming 4 times. What is the value? Each having the one value, that's why 4 value it is coming. For the marketing, how many times it is occurring? It is occurring 4 times and the value of each times is 1. That's why the sum of the marketing value is 4 only. Let's understand this ReduceByKey with the help of this pictorial representation. So suppose this is a one partition which is present in the one executor, and the value is A is equal to 1, B is equal to 1. So it is reduces in the same partition, okay, and it's become A1 and B1 because there's only one values are present in this partition for both key. Now suppose this is the another partition which present in the different executor. Here we can see there is a two value of key A. Here there are two value of key B. It reduces in the same partition, and it's become A is equal to 2 and B is equal to 2 because we are doing the sum aggregation. This is the partition which is present in third executor. Here we can see there are three value for key 1 and three values for key B, and it reduces in the same partition, and the value is 1 1 1. That's why it's adding it and become A key A is equal to 3 and B sum of the value is 3. Now at the last stage, what it is doing, it is creating two partition. One partition for is A and one partition is for B. So it is shuffle the data from this partition here. All the data which is associated with key A, it's come in this here. From here it is also coming, and from here it is also coming. So from here it is coming A is equal to 1. From this executor it is coming A is equal to B. Here is A and the value is B, and from this executor it reduces to A is equal to 3. The same value it is coming A is equal to 3, and in the same partition it is reducing. And what is the aggregation we are doing here? We are doing here sum. So A is equal to 6. 1, 2 and 3, you sum it up, you can get 6. That's why A is equal to 3. Same goes for the B. This value is coming from this executor, this one. This B2 is coming from this executor, and this B3 is coming from this executor. And once all the values are shuffled in this partition, or we can say this executor, now it reduces to one value. And what is the aggregate function we are assuming here? We are doing this sum. So this 1, 2 and 3, if you sum, then it becomes the value 6. In this way, reduce by key function works. You can see here during the discussion what I am just saying, it reduces in the same partition. During the reduction or reduce segregation, it is not shuffling the data in the different executor. It's do the aggregation or reducing in the same partition. And at the last stage, it shuffles the data from the different executors. So what I'm going to do here now, I am going to do exercise where I will show you how the reduce by key function works in Scala. So for this, I am just importing required library. Here I am importing the Spark session. Here I am just importing all the required variable or required functions. Here I am just creating a list. That list contains a pair data, key and value that we're going to use to create a RDD. Which RDD? We are creating this RDD with the help of a Spark context dot parallelize method by passing an object which contains the data. So this is the AP sample data. This is the type of list which we have created here. It contains the data. On top of that, we are going to call this reduce by key function. So reduce on top of this RDD, I am just calling this reduce by key, passing two parameters x and y. What I am just saying that just aggregate it. Aggregate it. Which kind of aggregation? Here the aggregation type is sum. Here same I am going to call the reduce by key on top of AP RDD and passing two parameters x and y. And I am just saying that which is the what is the mean value in each key. Here we are talking about in the each key, right? So it will going to give you the mean value. Here again we are just calling this reduce function, passing two parameters, and we are saying that what is the max value in each key. So each value will be going to be present in this respective RDD, and when we are just going to collect it, make it into what the collect will going to do, it will convert the RDD into the array, and we are just printing the value which is present in that array. So this is for the sum, this is for the mean, this is for the max, and this will be this aggregation, addition, mean aggregation, and max aggregation, it will be performed on the key label. So let's do this exercise in Databricks. Let me create a notebook. Let me name it as reduce by key function. So we need some data so that we can perform this reduce by key function. So I have created a list, okay, which contains the required data, and the data is in the form of list, key and value pair. You can see key and value, key and value, key and value, key and value. Now let's define this list variable. So list variable has been defined successfully. Now let's import all the required libraries. Import org.apache.spark.sql, and then here we are just importing Spark session. Now let's import all the functions. Import g.apache.spark.sql.function. So all the functions are available in this notebook. Now let's create RDD. How we are going to create the RDD? Spark.spark.context.analyze function, and we are passing the object which contains the data. So this is a list of object which contains the data here. So let me run it. Now this RDD gets created. Now let's use reduce by key to calculate certain kind of aggregation. Now let's do the first sum aggregation. AP on top of the RDD, this RDD, let's create reduce by, okay, well, that's why it's not coming. Reduce by key, and here we are passing two parameter x and y, and what we are just saying, just do a aggregation. Run it. This RDD gets created, and it has the data in the form of key and value after reducing or after doing a sum aggregation on top of this RDD. So how we are going to perform this aggregate RDD? It will perform the aggregate sum on each key. Let's print it, okay? Then we can able to understand it. Okay, this is tuple. So how we can print it? Here we can print it like this: collect for each and print it. Collect for each, collect then for each, and then print ln. We can see here it is coming. The output is coming for each key. So IT, management, marketing, and operation. We can see here IT, operation, management, and marketing. So we are doing which kind of aggregation? Sum aggregation. So for each key, whatever the value is present, it is aggregating. So we can see here that for IT, the total number of values present is 104. Management, total number of values are, if we sum it, values are 13. for marketing 303 and for the operation 302. Here, which kind of aggregation we have done? We have done sum aggregation. Now let's do max aggregation or mean aggregation first. Well, so on top of AP RDD, let's call reduce by key. Just pass two parameter x and y, and here what we are saying? Here we are saying that which is the mean value, return it. Let's so whatever the mean value for each key, it will getting stored in this RDD. Here what we are doing, on top of RDD we are just calling the reduce by key function, passing parameter x and y, and we are saying that whatever the minimum value for each key present, return it and store it in this RDD. Just print it. Collect dot for each. We can see for each key what is the minimum value it is present, it is showing here. For each key we can see one values are there. We can also validate from here also. Each key there is a one, the minimum value is 1 for each key. Like IT is equal to 1, operation has the minimum value 1, management has the minimum value 1, and operation has also has the minimum value 1. Now we have done the aggregation sum, we have done the aggregate function min. Let's do the aggregate function max. Okay, so let me create another variable AP and on top of APRDD, let's call this reduce by key function. Pass two parameter x and y, and what I'm saying here, x max y, whatever the max value, x or y, between them what is the max value, return it. So what it is doing here, it on top of this RDD, it is reducing by key and passing two parameter x and y, and what is the max value between x and y, return it and store it. And this do for each key, right? What is the max value for each key? It will going to calculate here and store in this RDD. So let's print this RDD. We can see this is the max value for 100 is the max value for IT key, 10 is max value for management, 300 is max value for marketing, and 200 is max value for operation. We can validate from here that IT, this is the maximum value for management, for operation, this is the highest value, for management, this is the highest value, and for the marketing, this is the highest value. So here we have seen that how we can do or we can perform aggregation on per key in the RDD with the help of a reduce by key. And which kind of aggregation we have done in this exercise? We have done three aggregations. Sum aggregation to figure out what is the minimum value per key and what is the maximum value per key with the help of a reduce by key function. Let's go to the PPT. Thank you. If you like content of my video, then please subscribe my channel, like it, comment on it, and press the bell icon to get notification whenever I add videos.